Good day, friends, and welcome to today's WASE online channel. I'm Philip, your instructor. But before we start our lesson for today, I need you to subscribe for our channel if you've not already done that. We need your subscription for the survival of this program. To do this, just go below this video and tap the subscribe button. Thank you so much for doing this for us. Now let's look at our activity for today. Today in set and set operations, we'll be looking at part 1. In our previous meeting, we looked at part 0 of this topic. In part 1, we'll be looking at 3 main headings. 1, we'll look at 3 ways of describing sets. Number 2, we'll look at how to list the elements or the members of a set. Then finally, we'll look at how to find the cardinality of a set. I believe you are ready for today's class. So can we start now? At this point, we'll be looking at some ways by which sets can be described. So we'll be looking at 3 main ways by which sets can be described. First, sets can be described by listing their members. The second way is done by using word descriptions or short sentences. Finally, we can use set builder notations to describe sets. Now, let's look at each of these descriptions in details. We'll start by looking at how to describe sets by first looking at the listing of members method. In this method, the elements or the members of the set are just listed in a curly bracket. We'll be looking at a few examples. Example 1 shows the set A. And as you can see, the members of the set A have just been listed. So we have 1, 2, 3, 4, and 5. So that's how we describe sets, by listing its members. And always remember to list the members of the set in a curly bracket. Example 2 shows the set M. And here again, the members of the set M have been listed. They are cat, goat, and cow. Example 3 shows the set B. Its listed members are Abuja, Nairobi, Lome, and Abidjan. And all of these are in curly brackets. Now, let's look at the method of word descriptions and simple sentences in describing sets. With this method, words or simple sentences are used to describe the members of a set. Let's look at a few examples. For example 1, we'll be using the set A. And as you can see in the set A, rather than listing the element or the members of this set, The members have rather been described in the curly brackets of this set. So A has members that are even numbers which are also less than 20. And I believe you know even numbers. And if we are asked to list all the even numbers that are less than 20, we can list them in this curly bracket of the set A. Example 2 shows the set M. And the set M is being described as the months of the year. Since we know the months of the year, January, February, March to December, we can convert this description method to the listing method, where we would list the individual months of the year within a curly bracket. Now let's look at our final example, which is the set B. And this has also been described as counting numbers between 4 and 16. Since we know what counting numbers are, for us to convert this description method or word description method to the listing method, all we need to do is to list all counting numbers that are between the numbers 4 and 16 in a curly bracket. Now let's look at the method of set builder notation. With this method, we'll be using the examples shown below to explain what the set builder notation is. Example 1 shows the set A that has been described in set builder notation format. So let's read what is in set A. So the set A equals to bracket x is such that 1 less than x less than 20. X is a counting number, bracket closed. So first, from this set notation, we know that x is a counting number. Now a careful look at the notation reveals that the x is greater than 1 and also the x is less than 20. So what we will say is this: x is a counting number greater than 1 and less than 20. So if we are asked to list the members of this set, what you do is to list all counting numbers that are greater than the number 1 and less than the number 20. As simple as that. Example 2 shows the set M. So let's read M. So M is equals to x is such that 2 is less than or equals to x less than 12. X is an even number, bracket closed. So the first important point we need to note about this set is that all of its members are even. Also from this set, we would realize that x is greater than or equals to 2 and x is also less than 12. So if we combine the two information, we would say that x is an even number which is greater than or equals to 2 and less than 12. So in the event that you are asked to list the members of this set M, what it means that you are listing even numbers that are greater than or equals to 2 and less than 12. As simple as that. Let's look at the final example, the set B. And we'll read the set B. So B equals to bracket x is such that 1 is less than or equals to x less than or equals to 17. X is a prime number, bracket closed. So first, we know that the element or members of the set B are prime numbers. We are also told that x is greater than or equals to 1 and less than or equals to 17. So what this means is that the members of the set B are prime numbers greater than or equals to the number 1 and less than or equals to the number 17. So in the event that you are asked to list the members of the set B, you are simply to list all the prime numbers that are greater than or equals to the number 1 and less than or equals to the number 17. As simple as that. So at this point, we've learned that sets can be described in 3 main ways. So first, we either describe it using the listing of elements format, or we use the word description format, or the set builder notation format. Usually, it is easier working with sets when they are in the listing format. So whenever a set is given to you and it is not in the listing format, it is always appropriate for you to first convert it into the listing format before using it for your work. So for example, if a set is given to you in word description format, first convert it to the listing format before using it for your work. The same applies when a set is given to you in the set builder notation format. First convert it to the listing format before applying it for your work. So remember this. So what we're going to look at right now is to learn how we can convert a set from a word description format or a set builder notation format to the listing format. So let's quickly look at how we can do this. But before we do this, I'll need us to look at the following important terms. So first, we'll look at natural numbers. Let's also remember that natural numbers are also referred to as counting numbers, and they are the numbers 1, 2, 3, 4, 5 to infinity. To remember what counting numbers or natural numbers are, the easier way to do this is to think about how you count items. So for example, if I give you some apples and I ask you to count them, how do you count them? You do not start from 0. You always start counting from 1. So the same way, counting numbers or natural numbers always start from 1 to infinity. As simple as that. Let's look at whole numbers. So these are the numbers from 0, 1, 2, 3, 4, 5 to infinity. To enable you remember what the set of whole numbers are, think about a whole, a bit. Bits usually have circular shapes, the shape of 0. So that would help you remember that whole numbers would always start from 0, the shape of a whole. Let's look at even numbers. Even numbers are the numbers 2, 4, 6, 8, 10 to infinity. And these are the easiest set of numbers to remember, especially for your level. So we do not need any trick to enable us remember what the set of even numbers are. Let's look at odd numbers. These are the numbers 1, 3, 5, 7, 9 to infinity. And I need you to remember that odd numbers are the exact opposite to even numbers. So the numbers that appear in between even numbers are odd numbers. So if you can give the set of even numbers, just figure out the set of numbers that appear in between these even numbers, and they are the set of odd numbers, and they run to infinity. Let's look at integers. Integers are positive and negative whole numbers. We know what whole numbers are. They are the numbers from 0, 1, 2, 3 to infinity. So if we want integers, we just get the negative of these numbers. But we need to remember that 0 cannot be negated. 0 is always 0. So apart from 0, we can negate 1, we can negate 2, we can negate 3 to infinity. And all of the negative numbers, the positive numbers, and 0 would come together to form integers. So it's as easy as this. Now, let's look at prime numbers. So we need to note that prime numbers are numbers that have only 2 factors. So the numbers 2, 3, 5, 7, 11 to infinity are prime numbers. You'd realize that to get the number 2, we just need to multiply 1 and 2 to get the number 2. So the 1 and the 2 are the 2 factors of the number 2. Also, to get the number 3, you realize that you need to multiply the number 1 to the number 3. So the 2 factors of 3 are 1 and 3. The same applies to 5. Its factors are 1 and 5. For 7, its 2 factors are 1 and 7. And for the number 11, its 2 factors are 1 and 11. Finally, we'll be looking at what the multiples of a number are. For the example on the screen, you'll be looking at the multiples of 3. So the multiples of 3 are 3, 6, 9, 12 to infinity. So what we simply did was to do 3 times, as simple as that. So multiples of 4 would mean 4 times. Multiples of 5 would mean 5 times to infinity. So that's how simple this is. Now that we know what all of these terms stand for, we are going to use them to generate listing sets. Supposing a set is given to us in either word description format or set builder notation format. So we're going to use these terms to generate our listing format sets. So let's look at example 1. For example 1, we have the set A equals to even numbers between 10 and 24. Set A is in word description format, but we want to convert it to listing format. So first, we need to remember what even numbers are, and we also need to know the even numbers that are between the numbers 10 and 24. So let's look at the solution to this problem. This is the listing format of the set A. We have the numbers 12, 14, 16, 18, 20, and 22. These numbers are even numbers, and they also appear between the numbers 10 and 24. Like we said, the numbers 10 and 24 are not included in this set because this set of numbers A should be between those two numbers 10 and 24. Let's look at example 2. For this example, we have the set X. The set X includes counting numbers less than 14. So we first need to know what counting numbers are. Then we also need to know the counting numbers that are less than 14. Remember, our answer should be less than 14. So that means that the number 14 should not be included in this list. So let's look at the solution. We have set X in its listing format. We know that counting numbers start from 1 and they run to infinity. So counting numbers less than 14 should be 1, 2, 3 to 13 without 14 because our answer should be less than 14. So that is the answer. Let's look at example 3. So we have the set M, and here the set M is in set builder notation format, and our work is to convert it to the listing format. And let's read what is in the set M. We have X such that 1 less than X less than or equals to 17. X is an odd number. Bracket closed. First, from the set M, we are told that the members of the set M are odd numbers. We also need to note that X is greater than 1. It's also less than or equals to 17. So what this means is that we would list all odd numbers that fall within this range. So let's look at our solution. So this would be the listing format of set M. So our set M will be equals to 3, 5, 7, 9, 11, 13, 15 and 17. And as you would realize, all of these numbers are odd numbers. Again, the number 3 is greater than 1. Also, the number 17 within the list is equals to the 17 given to us in the set notation format. Remember that x should be equals to or less than 17. So 17 would have to be included in the list. So that's how come you can see 17 included in the list. So that's how we do this. Let's look at example 4. In this example, we have the set y. Set y is also in set builder notation format, and it reads x such that 4 is less than or equals to x less than or equals to 36. X is a multiple of 4, bracket closed. As we can see from the set, the members of y are all multiples of 4. Also, the x is greater than or equals to 4. X is also less than or equals to 36. What this means is that the members of the set y are multiples of 4 which are greater than or equals to 4 and less than or equals to 36. Anytime you have something like this where x is greater than or equals to 4, what this means is that because of the equal sign, the 4 should be included in the list. The same way, because the x is less than or equals to 36, 36 would also have to be included in the set or the list. With this, let's look at the solution to example 4. This is how the set y will look like when we list all of its members. And as you can see, all the numbers or the members of the set y are multiples of 4. And you would also realize that we started from the number 4 and we ended with the number 36, because those two numbers would have to be included in the list. At this point, we'll be looking at how we can find the cardinality of sets. So, the cardinality of a set simply refers to the number of elements or members in the set. Let's look at an example. So for example 1, we have the set A. The set A is made up of the elements 2, 4, 6, 8 and 10. When you count these elements, they are 5 in number, which means that NA, which is used to represent the cardinality of sets, is equals to 5. Let's note that the cardinality of the set A, which can be written as n into bracket capital A, can also be written as A absolute, as shown on the screen. Let's look at the example 2. For this example, we'll be looking for the cardinality of the set M. The set M are odd numbers between 2 and 18. For us to find the cardinality of this set M, it is important that we first convert this set notation to the listing notation. So we first have to list the members of the set M, then afterwards we'll find the cardinality of the set M. So these are the elements or the members of the set M. You'd realize that all of these elements or members are odd numbers, and also they are between the numbers 2 and 18. 2 wasn't included in the list. 18 was also not included in the list, because we are looking at odd numbers that are between these two extreme numbers 2 and 18. When we count the number of elements or members in the set M, our cardinality will be equals to 8, because there are 8 elements or members in the set M. Let's look at example 3. For this example, we have the set G. And as you can see, the set G is in set builder notation format. So it will be appropriate for us to first convert it to the listing format and use that to derive our cardinality of the set G. And as you can see from the set builder notation of the set G, you realize that all the members of the set G are counting numbers, and they are greater than or equals to 1, and they are also less than 14. So we would have to list all counting numbers that fall within this range, that are equals to or greater than 1 and less than 14. So there will be 1, 2, 3 to 13. Remember, 13 is less than 14. So remember, 14 will not be part of the list, but 1 will be part of the list because x is equals to 1. So let's do that. Just note that anytime x is greater than or equals to a number, then that number must be included in the list. That is how come we included the 1. So we need to note this carefully. At this point, we can count the number of members or elements in the set G. And when we do this, we would realize that we have 13 elements in the set G. So therefore, the cardinality of the set G will be equals to 13. Well, friends, this brings us to the end of part 1 of sets and set operations. You can now go to the second video, which is the part 2 of sets and set operations. And in part 2, we'll be looking at subsets, then operations on sets. Thank you very much and stay safe. But remember, if you've not already subscribed for this channel, please move below this video and tap the subscription button. Thank you so much. Stay safe once again.